Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way of keeping me going, refreshed, and inspired. Now, if you find my videos interesting and important to your studies, also don't forget to subscribe. Analyze the non-sway frame shown below by slope deflection equations, constructing the shear force and bending moment diagrams. Also sketch the elastic curve, and EI is constant. So the reason why this frame is a non-sway frame, it's because of the restraint present at the top level. So by applying a force horizontally or laterally, this frame remains in that position because of the restraint at A. So that's why it is a non-sway frame. So in this frame, we will select the top part as the top fiber, the right side of each column as the top fibers. So let's have the slope deflection equation for portion AB. So moment AB is 2EI over L, quantity 2 times theta A, which is 0, plus theta B minus 3 times delta over L. Delta is 0 because it is an unsway frame. The beam remains horizontal. Then minus fixed in moment at A, which is WL square over 12. So negative 35, 5 square over 12. So simplifying, we have 0.4 of theta B minus 72.917. Call that equation 1. Moment BA, on the other hand, is because theta B will be doubled, so this becomes 0.8 theta B, and the fixed moment will be the positive of this because of symmetry. So moment BA is 0.8 theta B plus 72.917. Equation 2, or you may set up that. So the explanation is it's the same. Moment BA 2 times 1 over 5. Quantity 2 times theta B. So 2 times theta B, then plus theta A, which is 0, minus 3 times 0, then plus 35, 5 square over 12. So that's the result. Next is moment BC, which is also symmetric. So moment BC is 2 times 1 over 9, quantity 2 theta B plus theta C minus 3 times 0, then minus 35, 9 square over 12. So MBC is equal to 4 over 9 theta B plus 2 over 9 theta C minus 236.25. Call that equation 3. Then the shortcut to MCB is you interchange coefficients, then you make this plus because of symmetry. And the moment CB is positive at the right side. Then we have to set up moment BD. Moment BD is 2 times 1 over 8, quantity 2 theta B plus theta D 0 minus 3 times 0, no side sway. There's no load, so that's the equation. Simplifying, we have 0.5 theta B, moment BD. Then call that equation 5. Moment DB, on the other hand, it is theta D that is doubled. Theta B will just be theta B. So therefore, because theta D is 0, therefore the equation is moment DB is 0.25 of theta B. Call that equation 6. You can verify that if you want the detailed equation. Then moment CE is 2 times 1 over 6, quantity 2 theta C plus theta E, with 0 minus 3 times 0. No load, so that's the equation. MCE is equal to 2/3 of theta C. Then moment of EC is it is theta E that is doubled, so the coefficient of theta C will just be 1. So it is 1/3 of theta C. That's moment EC. Then we now have to set up equilibrium equation at B. MBA plus MBC plus MBD equals 0. So MBA is 0.8 theta B plus 72.917. MBC is 4/9 theta B plus 2/9 theta C minus 236.25, and MBD is 0.5 of theta B. So that's the reason why the result is this. Combining like terms, then setting up the first equation. There are only two unknowns here, 157/90 theta B plus 2/9 theta C equals 163.333. Call that equation A. Then for at C, MCB plus MCE equals 0. MCB is this one, 2/9 theta B plus 4/9 theta C plus 236.25 plus MCE, which is 2/3 theta C, equals 0. Combining like terms, simplifying, so 2/9 theta B plus 10/9 theta C equals negative 236.25, equation B. Solving these two equations simultaneously, we get theta B equals 123.872 over EI. Theta C is equal to negative 237.399 over EI. Having found these slopes, then we can now have the moments. Moment AB is equal to 0.4 of 123.872 minus 72.917. So moment AB is equal to negative 23.368 kilonewton meter. MBA is equal to 0.8 of 123.872 plus 72.917. So MBA is 172.015 kilonewton meter. Therefore, next is MBC, 4/9 of 123.872 plus 2/9 of negative 237.399 minus 236.25. So MBC is equal to negative 233.951 kilonewton meter. Next is MBD, which is equal to 0.5 of theta B, 123.872. So MBD is 61.936 kilonewton meter. Then MDB is 0.25 of 123.872. So MDB is 30.968 kilonewton meter. MCE is 2/3 of theta C, so negative 2/3 of negative 237.399, negative 158.266 kilonewton meter. So if MCE is, or moment at C is negative 158.266, then MCB is positive 158.266. MEC, on the other hand, is 1/3 of theta C. So it is equal to negative 79.133 kilonewton meter. Again, MCB is positive 158.266. So it is not shown here, but that's automatic because there are only two members attached to C. So if MC is negative, then MCB would be positive, same value. So let's have the results from the preceding slides. For the moments, these were the results. So we now compute the other reactions. So let's denote those reactions, then shear, and so on and so forth. Let's assume that the moments are positive as shown in the figure. So let's apply the actual moments. So moment AB is negative, so it is as shown counterclockwise. Moment BA is positive, so clockwise by slope deflection equation. So moment AB or moment A is counterclockwise because it is negative. BA is clockwise by slope deflection equation. BC is counterclockwise again because it's negative. BD is positive, so it's clockwise. DB is positive, so clockwise. CE is counterclockwise, negative. And EC is counterclockwise, also negative. So considering AB, summation moment B equals 0, so AY times 5 plus MBA, which is 172.015, equals moment A 23.368. It's now positive because it is the correct direction. Then plus moment of the load 35 times 5 times 2.5. So from there we can solve AY equals 57.771 kilonewtons. Then shear at B just to the left, summation moment A times 5 plus moment A 23.368 equals moment at BA 172.015 plus moment of the load 35 times 5 times 2.5. So shear at B just to the left is equal to 117.229 kilonewtons. Next is shear at B just to the right to solve for dy. Considering BC, so shear at B just to the right times 9 plus moment CB, which is 158.266, equals moment BC, which is 233.951, plus moment of the load 35 times 9 times 4.5. So shear at B just to the right is equal to 165.909 kilonewtons. So we can now solve for dy. If you draw the free body diagram of this column, then action reaction, so downward for shear B left and shear B right. So dy is just the sum of shear at B just to the left and shear at B just to the right. So dy is equal to 117.229 plus 165.909, 283.138 kilonewtons. Then considering column BD, you sum up moment about B equals 0, so dx times 8 equals this moment BD 61.936 plus this moment, these are all clockwise moments, 30.968. So dx is equal to 11.613 kilonewtons. So let's solve shears at C just to the left, because if you draw free body diagram of column CE, it is CY. So shear at C just to the left times 9 plus moment BC, which is 233.951, equals moment CE, which is 158.266, plus moment of the load. So this equation is, we consider BC and we sum up moments about B. So computing shear at C just to the left, which is equal to EY, is 149.091 kilonewtons. So EY is 149.091 kilonewtons. Then to solve for EX, you sum up moment about C equals 0 considering this column. So EX times 6 equals this moments here, 79.133 for EC, and for CE 158.266. So EX is equal to 39.566, and it is leftward as shown in the figure. So since we select upper fiber as top fibers, right fibers as top fibers, then to solve for AX, we consider the whole system. AX plus DX equals EX. So AX is unknown, DX is 11.613 rightward, then equals EX, which is leftward, 39.566. So AX therefore is 27.953 kilonewtons rightward. So we are now ready to sketch the shear force diagram. First, from here, we rise by AY, which is equal to 57.771. Then minus 35 times 5. So we have a line here. And it is equal to negative 117.229. Again, 57.771 minus 35 times 5. You'll get this. This is supposedly equal numerically to the shear at B just to the left. So it checks here. Then this distance is 57.771 divided by 35. Or you may get this distance by similar triangles. Then for BC, we have shear at B just to the right, which is 165.909. Then minus 35 times 9, we have the same shape of curve. And it is equal to negative 149.091. It is shear at C just to the left. So it checks. Then the distance 1.6506, 57.771 divided by 35, or you get that by similar triangles. Therefore, this is 5 minus 1.6506, so 3.3494 meters. This distance is 165.909 divided by 35, and that's 4.7403 meters. This is 9 minus 4.7403, so it is 4.2597 meters. Now in this portion, because this is the top fiber, so the shear here is going to left, and it is equal to 11.613 treated negative, because this is the top fiber. And for this portion here, so this is the left, this is the right, because the top fiber is here. So therefore we move right equal to EX 39.566, then constant, then it closes here because we have EX 39.566 going left. Then for that's a shear force diagram in kilonewtons. Then let's have the bending moment diagram in kilonewton meter, beginning with A. The moment A is negative, so going down, negative 23.368. Then plus the area here, which is, so we have positive decreasing. Area is 1/2 of 1.6506 times 57.71. Add it to negative 23.368, then we'll have equal to 24.310. Then we have negative decreasing curve, 24.310 minus the area here, which is 1/2 3.3494 times 117.229. You'll get negative 172.013, which is supposedly moment BA, the magnitude. So 172.015, that's a very, very small discrepancy. So that's okay because of the rounding off of these distances. Then moment BC is negative 233.951. Then plus this area of triangle, 1/2 of 4.7403 times 165.909, and it is positive decreasing curve. So you'll get value of 159.278. Then 159.278 minus this area, 1/2 of 4.2597 times 149.091. You'll have here negative 158.263, which is supposedly MCB, or this one. So it's very close, that's fine. Then for this part, moment, this is the top fiber, moment BD is, so this is the left, this is the right. Moment BD is 61.936. So it's positive 61.936. Then minus this area here, which is 11.613 times 8. And we have straight line, positive 61.936 minus the area 11.613 times 8, and you will have negative 30.968. Then it closes, moment dB 30.968. Then this part, again, this is the left and this is the right. So moment CE is negative 155.236 here. Then plus the area 39.566 times 6. We have a straight line. So negative 158.266 plus 39.566 times 6. You'll have here value of 79.13, which is very close to MAC. So that's the bending moment diagram in kilonewton meter. For the elastic curve, so for this part here, we have concave down and concave up, concave down again. For portion BC, concave down and concave up, concave down because of this negative moment, then negative, concave down, and there's a portion which is positive. For this part here, we have, this is the top fiber, so it is positive like that, then we have a negative value. So therefore the elastic curve will be approximated as shown. So that's it, and that's the mentioned approximate elastic curve for this problem.